Hello, everyone, and welcome to the second coding tutorial for the 2023 season/year in terms of coding in R. For those of you who don't know me, my name is Arjun Menon. I am the president of the Michigan Football Analytics Society for this upcoming school or for this school year. Super excited to be making the second tutorial. Got a lot of positive feedback on the first one. Um, and the agenda for today, we're really just going to dive into some of the new public NFL data that has come out. So I'm recording this a couple days after Christmas. About a week ago, the NFL Radar team, made up of guys like Ben Baldwin, Sebastian Carl, John Edwards, Tanho, they basically added a couple new columns to public NFL data, which included NFL coverage data like cover one, cover two man, NFL coverage data in terms of man or zone, whether a quarterback was pressured or not. So we're really just going to dive into that, come up with some insights, and we're going to create some cool stuff like some tables and some interesting things revolving around measuring unpredictability in football. So super excited for this one. Super excited to dive into it. As usual, first though, do want to give a plug to our channel. If you're here, you're obviously on the channel, but this is, I would say, is another kind of intermediate type video. If you're just getting started and you want to kind of learn the basics, I would recommend these former tutorials by my predecessor, Tage Seth. So I would recommend this one, the Introduction to NFL Data with R 2022, or the one he made initially, which is Introduction to R with NFL FastR. So these two are made available for anyone. So if you want to start off with those, go ahead. But I'm going to share my screen and we're going to start coding like we did last time. So first thing we got to do, as always, when loading in a or opening a new R Studio console, we're going to need to load in some libraries. So the libraries we're going to load in. Um, I'm actually just, I would recommend writing these all out. I'm just going to copy paste it uh, from my GitHub link. And also, let me just share this real quick. All of this code will be made public. You can just go to my GitHub at ArjunMenon10, MFans Coding Tutorials, tutorial number 2. Anything I write on the R Studio console right with you guys will also be made public here so you guys can reference. But to go back to the coding, again, these are all the libraries that we're going to need to make some of the stuff we're making today. We've kind of don't need these two, but we've already kind of done a lot, explained a lot of these. This one is the package that pulls in the data. This is a package that helps to clean and manipulate data. These are this package for making, or these two packages are for making tables. And then these are for creating graphs, which is what we're going to do today. And I'm not sure we did that last time, but the first thing we're going to want to do is load in the data. So we're going to do PBP, which stands for play by play, load participation, the 2023 season, and we want to include the play-by-play. So this, I've already run it just so we don't waste time. Obviously, you can open it. You can see here. Uh, so you can see here, this is what it looks like. You have, the play ID, the offensive personnel, defensive personnel. You have number of pass rushers. But again, the main things we're going to be using today is this column, the defense coverage type. And for those who may not be familiar with public NFL data, this is like the crown, one of the biggest things that's been added. Everyone's always been clamoring for coverage data just because it's such a vital piece of analyzing the NFL for anyone. So this is a pretty big addition. And so we are going to, try and come up with some really cool insights. So the first thing we want to do, obviously, coverage data, it really only applies to pass coverage, right? So on passing plays or dropback plays. Um, you can call a pass coverage when there is a run play, and some companies like PFF or like SIS, they do chart, I think, coverages for run plays. But for the sake of this, you can see there's a lot of NAs, which is basically because the columns are only charted, or the coverage type is only charted for pass play. So what we're going to do is we're going to filter the play-by-play data frame that we created, and we're going to say pass equals 1, just so we are only looking at pass play. So as you can see here, the play-by-play shrinks down to 18,000 rows from 39,000 rows. And so that is only looking at passing plays. Next thing we want to do, let's do some data exploration. Let's just see, what are we looking at? So we obviously are looking at the coverage type. So the unique function basically tells us all the different types of coverages there are in this data set. So when we run this, you can see at the bottom, we have cover 3, cover 4, cover 1, cover 0, NA. So that's going to be important. Cover six, cover two, two man, and then prevent defense. So as you can see, a lot of different coverages. We have kind of the main coverages that people like to look at or reference. But I don't really like how this is formatted, right? We have an all capitals cover three with an underscore there. So for formatting purposes, we're actually going to change this. We are going to look at, or we're basically going to change the names of this. So what we're going to do is we're going to take the play-by-play data set and we're going to use the mutate function. And what we want to do is we want to change these names. So how we do that, we're going to do coverage types, difference coverage type equals case when. And so what case one basically says, if you state a case, it will change the name or create a new name for a specific column. So again, we want to change this column and we want to just change how this looks. We just want to change kind of the phonetics or the just kind of how it's spelled out, right? We want it to be like uppercase and lowercase with the space in between the cover and the number. So case one, defense coverage type, double equals cover zero, and then we're going to use this symbol and say this is cover zero. So again, to kind of just read this, we are mutating, we're changing this column name when the column name equals cover zero. We're going to change it so that it looks like this, like a normal way of how people would represent it. And basically, we're going to just do this for every coverage type. So again, defense coverage type equals cover one, and we're going to change that to cover one. For the sake of time, I'm just going to, do a little copy paste. I'd recommend writing this out just so it's, it kind of sticks in your mind about how this is supposed to be formatted. But, I completely understand if maybe this is also beginner level for you. But the last one we're going to do is two man, and we're going to say it's like that. Now we also, so these are the main coverages we want to look at. We don't really care about prevent defense. No one really cares about it. You talk to any coach in the league, they'll probably say prevent defense on plays against prevent defense don't matter. So what we want to do is there's two types of coverage types we're not looking at. We're not looking at we haven't created a case for the NA plays and the prevent plays. So what we're going to do is when none of these, when the coverage type does not equal any of these uppercase ones, we're going to just call it other. So we're going to run that. And then let's just go back up here and see what we're looking at. And you can see all of the coverage types have now changed to, like a normal looking thing with the other one. But I think it's important to understand kind of why there is an other. So, one thing I did want to show, and this is something I did on my own, but I'll show it to you guys, is we need to like explore why is there an other, right? So if we do play by play, we're going to filter it so that quarterback scramble equals one, which basically means the quarterback did scramble on the play. Let's select the QB scramble column and defense coverage type. And you'll see why I'm doing this in a second. So we do that. You can see on any play that a quarterback scrambled, the defense coverage type is other. Now remember, the only reason why the defense coverage type would be other is because initially it was charted as an NA or a prevent defense. Now, prevent defense happens like less than 1% of the time for most defenses. So that does mean almost every single one of these other rows was an NA. Now, why is that the case? Why was there no coverage charted? Well, technically, the quarterback didn't throw the ball. So, this data is pulled from Next Gen Stats. So maybe they didn't have the coverage charted on plays where the quarterback did not throw the ball. Now, what other type of thing can a quarterback do that involves them not throwing the ball on a play? Taking a sack. So what we're going to do is we're going to see if this holds true for plays where the quarterback is sacked. So we're going to filter to where sack equals one, which basically means a sack happened on a play. And let's look at the same thing. So we're going to run this, and you can see on plays when there's a sack, there is no coverage charted for any play, which it sucks. Like that's just how it is. That's kind of the thing about dealing with public data. You're not always going to be able to scrape everything. Not everything's going to come out perfect. So what does this tell us? Well, this introduces a selection bias in the data. we're only looking at plays where the quarterback threw the ball, like actually released the ball to an intended target, or it was a throwaway. And I believe those are charted. So sacks are obviously a huge negative play, in terms of the data that we like to use in the analytics community for EPA, expected points added. Sacks are one of the most negative plays you can have from an EPA perspective. Scrambles are mostly a positive play because a quarterback scramble, you are gaining yards unless it's a 1 yard run, which then it wouldn't be valuable. But there is some selection bias from both sides that we're removing some valuable scrambles, but most quarterbacks take more sacks than they actually scramble. So we're removing a lot of the negative plays, which means a lot of the data we look at in terms of the EPA per play, in terms of success rate, in terms of net yards per play, they're going to be skewed because we're not looking at any sack play. So that's something to keep in mind. That's what you do when you do some data exploration. You always want to make sure you're looking at what is and what isn't being looked at in the bigger picture. So, the thing we want to do today is the first thing we're going to do is measure unpredictability in football. This is one of my favorite concepts. This was introduced by Eric Eager, my former boss at PFF, now VP at Sumer Sports. I'll get into what we're going to do first, but in a little bit. But let's first just look at some data. So, how do we access this defensive coverage type? What are we going to do with it? Let's get into it. So we're going to create a new data frame called coverage, which just basically stands for coverage rates. We're going to take the data from the play-by-play data frame. So what we're going to do, we've already filtered to passing play, so we don't need to do any more filtering. We're going to group by def team, which is the defensive team, and the defensive coverage type. Then what we're going to do, we're going to summarize and say, we're just going to say the number of plays that each defense runs with each coverage type is n. So n just counts the number of rows it happens. So let's just run this and see what we get. We get a data frame with 252 rows and 3 columns. So as you can see, this lists the defense, the coverage type, and the number of plays. So we can see how many plays the Arizona Cardinals have run of cover 0, cover 1, cover 2 that didn't result in a sack or a scramble. So like on plays where a quarterback actually threw the ball, this is how many times the Cardinals or any team ran each coverage. Okay, now let's go a little bit deeper. Let's create some more columns. Let's look at some more data. So we're gonna ungroup, and we're only gonna group by, or I guess let's not do that. Let's just do group by def team and not the coverage type, and you'll see why in a second. And let's filter so that the defense coverage type is not other. Because again, we don't really care about the plays where the coverage wasn't charted, because what are we going to do with a non-charted coverage, right? So we're going to filter the non-charted coverage plays, and then we're going to do another mutate, which is still grouped by the def team. And in the mutate, we're going to say the total number of plays for each defense is the sum of this column. So we want to, so let's just run, and actually let's wait. We want to sum up all of these numbers right here, except the other column. So we're going to sum up all of these, and that's what this total plays is doing. And then we're going to say the rates is the plays divided by the total plays. Boom. Now what do we get? So we get the number of plays that each defense has run with each coverage. We have the total number of pass attempts or plays where the defense has run a coverage in general. And then we have the percentage of which is basically just the plays divided by the total plays. So the Cardinals run cover 0 7% of the time. They run cover 1 14% of the time, so on and so forth. You can go here, you can filter it. Let's look at the Chargers. That's my team. Their most used coverage is cover 3. They run it about 29% of the time. And then they run cover 6 about 23% of the time. So that's, what we're looking at. But, there are some things that we want to do with it. Like this isn't I think a great way to kind of display the data. It's not really what we want to look at. So what we're going to do is, first of all, we're going to remove the plays and total plays column, just because we already have the rates, and that's what we actually care about here. So let's remove those two. And then again, let's group by def team. And what we're going to do is we want to make each coverage its own column, and you'll see why. But we want to make each coverage its own column, and in that column we want the rates. just so it's first of all, it's easy to filter for each team, and it'll be in one nice data frame with only 32 rows. So what we're going to do is the pivot wider function. Now, this is one of the best functions in R, in my opinion. It's also one of the hardest to use. And anytime I've used this, I've needed to look at the documentation. Luckily, since I'm doing the tutorial, you won't have to. So we can just kind of read what this function does. So base or indicates. So what we want to do is we need to say where are the names of the columns coming from. So the names from comes from the defense coverage type, because again, we want this to be the name of each column. So the names for each column come from defense coverage type. And the values, which is like where do we want the numbers to come from? That's going to come from the rates. So again, let's just double check again. This is what it looks like before. Now let's run this. 252 something rows, 230 rows drops down to 32, and we get the rate for each team for each defense in each coverage. So Vikings have the most snaps to cover 0. Dallas has the most snaps to cover 1. The Vikings have the most snaps to cover 2. You can do that for any column, right? And for what we're going to do, we want to kind of remove the NAs. Really, there's only a couple NAs for teams that don't run cover 2-man, which that happens. Again, they might have run cover 2-man, but it might have resulted in a sack or a scramble. So what we're going to do is cover rates. We're going to use bracket and do is.na cover rates. And we're going to say basically what this is saying is any column, which is indicated by the bracket, any column that is NA, we want to turn into 0. And as you can see, you have some teams like the Cardinals who have 0 snaps to cover 2-man. This initially was an NA, and now it's 0. So now what we're going to do is we're going to measure unpredictability. It sounds like a big project. It sounds like a big thing. It really isn't. It's a very simple calculation. I'm going to go back to Chrome real quick, or my browser, and I'm just going to share this article again by my former boss Eric Eager, one of the smartest people I know, PhD in applied math, now VP at Sumer Sports, who introduced me to this idea. And he was initially doing it for measuring versatility in coverage players, and I decided to apply it to measuring unpredictability in NFL defensive schemes. So again, so we're going to be looking at a thing called a measure called Shannon entropy. So what it is, it's basically just gathering information and determining how likely is it that we can predict what's going to happen. So the formula for Shannon entropy here is the sum of each of the probabilities multiplied by their logarithm base 2 and everything multiplied by -1. So again, this basically just says if we go here, we want to take all of these probabilities, multiply it by -1, and we want to take the base 2 logarithm of all of these probabilities multiplied by -1, and it'll give us a number that basically says how predictable is a NFL coverage or NFL defense. Again, I think you talked about it here, but the closer that the number is to 0, that means it is more predictable. The further away from 0, so the larger the number, the more unpredictable the coverage scheme is. So again, let's go back to our code. Basically, so the idea of this is like if we look at this, Indianapolis runs cover 3 54% of the time, right? That is one of the largest percentages of any coverage. That is the largest percentage of any coverage. So we can say like we could predict, or we could reasonably say that Indianapolis is going to run cover 3 on any given play, right? But we want to quantify that. Like we want to say, okay, this is actually compared to other NFL defenses, this is how concentrated Indianapolis coverage scheme is around one coverage. Whereas a team like, we'll see later, but like Baltimore, there isn't really a coverage they run super often that, is like overpowering. So you can see with Baltimore, it's like 8% cover 0, 21% cover 1. There's no 1% there's no one coverage that they run over 25% of the time. They have a very diverse coverage scheme, but again, we want to be able to quantify that. So the way we do that is let's use our cover rates data frame. And again, we're going to use the mutate function, and we're going to say Shannon equals and again, so we're going to multiply -1 to the probability. And so because the columns have a space in that, we have to use this little, I'm not sure what the symbol is called, but basically if you type in cover, you'll see like it'll turn the thing into this, put it inside that. Again, I don't know what the symbol is called, but we're going to use that. We have to use that symbol. And again, we want to multiply it by the log of that, the probability of that to the second base. So this is what it looks like. And again, we're going to do that for every coverage. So we're going to say minus cover 1 times the probability, or the probability of cover 1 times the logarithm of that coverage, base 2. And again, let's just, for the sake of time, you can just kind of copy it, and go from there. So again, let's just change all of these. Cover 1, let's make this cover 2. Let's make this cover 3. Let's make this cover 4, cover 6. And then we need one more for 2-man. Okay. So again, this is the formula that Eric talked about in his article. All right, guys. Sorry, real quick. I paused the recording. You might have noticed a little break or whatever, but there's one thing we had to add. Or not unfortunately, just one thing we had to add. Basically, with the entropy calculation, you can't really have, or at least in R, you can't have any of the columns be 0 like there is for cover 2-man. So what we have to do is we have to just include like a little adjustment in case there's anything. So what I did, you noted, like, it's not a big change. Basically, inside the logarithm, after the coverage name, I just did a plus and then NUG. And so what I did is I set NUG equal to this value, which is basically 0.001. It basically just, it moves everything so that there is a value for each column that is in 0. So this is something Eric had told me, and I completely just forgot initially. But again, if you can include the plus NUG, so first write this out, NUG 10 to the power -3, and then include the plus NUG inside the log right after each coverage, just like is shown on my screen and in the tutorial. Then it should run, and there shouldn't be any NaNs. So as you can see, no NaNs now. Perfect. So now what do we have? We have a list of the Shannon entropy for each defense, and it basically just tells us which defenses are the most unpredictable, or which defenses have the most diverse coverage scheme. The Kansas City Chiefs have the most diverse coverage scheme in the NFL right now. You can see 7% cover 0, 23% cover 1, 20% cover 2, 15% cover 3, 22% cover 4, 6% cover 6, and then 8% cover 2-man, which is the highest in the NFL. So very diverse. They run a lot of different coverages. On the other side, like I talked about, Indianapolis, when you have a coverage you run over 54% of the time, like that, you're not going to be a very unpredictable defense. Like teams are gonna know what you run. Now, for some defenses, that doesn't matter, right? Like you can see here, the Browns are the best defense in the NFL. At one point, they had the most, they had the best defense in like the past decade. So let's look at whether any of this stuff really translates. Is this predictive, or is this really just a descriptive metric? So what we're gonna do now is we're gonna go back to our play-by-play. So we're gonna create a new data frame called defensive EPA, or def EPA. We're going to group by def team and summarize and say EPA per play is equal to mean EPA. And we want to remove any of the NA. So again, this data frame is basically just saying defense and then how, their efficiency. So checks out, Browns are 1, Browns are 1, Ravens are 2, Chiefs are 3. And again, we are only looking at pass plays in this because we want to compare pass coverages with passing efficiency allowed. So again, what we're going to do now, we want to join this column in the def EPA to the cover rate. So we're going to create a new data frame called Shannon all. We're going to do a left join of cover rates with def EPA. So basically we want to join these two data frames, and the common variable in each data frame is the def team. So we're going to do by equals, inside a apostrophe or a quotes, we can do by equals def team. And here we go. So now we have the Shannon entropy and the EPA per play for every team in the league. So now let's create a graph. So we're going to do Shannon all pipe and then ggplot. And we're going to do AES, which stands for aesthetic. X, we want the x-axis to be the Shannon entropy for each team. And we want the y-axis to be the EPA per play. We're going to use the plus symbol, and then we're going to do geom image. And so with that, we're going to do image equals Shannon all. We want to use the, oh, hold on, I forgot one thing. With this inside, or when we do, sorry, when we do the Shannon all, we want to also join it with team logo so we can make our plot. So after doing the left join, we want to do another left join with teams, logos, colors by equals, and then C, def team equals team abbreviation. What we're basically doing here, you can see the team's logos, colors, data frame. We want to join this abbreviation, which is the def team column, to this abbreviation in the team colors, logos, data frame, which has a different column name. So we have to say def team equals team abbreviation. And as you can see, when we click on the Shannon all data frame, we have a team logo here. So here again, we're going to do team logo ESPN. This is the aspect ratio, just so the image comes out really clean. And then we're going to say the size equals 0.05. So next, what we want to do is we want to just include some lines on the graph to look at the averages. So we're going to do GMH line, which is basically a horizontal line on the y-axis, and we want the y-intercept to be the mean of the Shannon all data frame, and then the EPA per pass. We're going to do line type equals dashed and color equals red. We're going to do the same thing, but we're going to do a vertical line now on the x-axis. So the x-intercept is going to be the mean of the Shannon all and our variable on the x-axis, which is the Shannon column. Line type equals dashed, again, inside an apostrophe, and the color is going to be red. So we run that. We should be able to see a graph in the plots column finally. Okay, now that the graph is loaded, we can just, you can either click zoom. That I'm not able to really show that then, but this is what it looks like, right? So what we see is the x-axis is how unpredictable every defense's coverage scheme is, and the y-axis is the EPA per pass allowed. Now the x-axis is correct because we want it to go from left to right, most unpredictable on the right, least unpredictable on the left. But the Browns are not a bad team here, right? The bottom left quadrant should be the worst teams in this. So we need to flip the y-axis. But before we do that, we're also going to, make the graph look pretty. We're going to add some titles. We're going to, spice it up a little bit. So first thing I like to do is add a theme to any of my graphs. I just realized we also, or should be there. Theme 5, there we go. So I used to use theme 538. It's one of the cleanest themes out there in my opinion. So we're going to do that. Then we're going to do labs. The title of this is going to be, and I'm just going to copy paste this actually from my GitHub to save time. The title is going to be coverage predictability and defensive pass efficiency allowed for NFL defenses in 2023. The caption is going to be by Arjun Menon, at Arjun Menon 100 which is my Twitter, and then data is NFL Radar. And then the subtitle, just to kind of explain what we're showing to people. This is what I did, or this is what I wrote out, which is predictability, only looking at coverage schemes. We want to just explain that we're only looking at coverage schemes. We're not looking at defensive fronts, formations, personnel usage. Like that is a completely different thing. We're only looking at defensive coverage schemes here. Next thing we're going to do, we're just going to change some of the like axis titles just so it shows up nicer and it shows up a little bit bigger. So we're going to do axis title equals element text, which basically allows us to change the size. We're going to make it size 18. Then we're gonna change the name of each of the axis titles. So the X lab, which is basically the X, basically how we change the name of this the Shannon to be a different name. We're gonna do coverage scheme Shannon entropy. And then the Y axis, we're going to change to EPA per attempt allowed. And again, we're not using EPA per play. We're not using EPA per drop back because, again, the data we have is it only gives coverage schemes for plays where the quarterback threw the ball. So we have to use EPA per attempt. Again, that is skewed. Can't really do much about that. Then we're going to just do a bunch of other themes. We're going to do panel, grid, minor equals elements blank theme. Let's see, axis dot text is element text. We want to make the numbers a little bit bigger, so we're going to do element text size equals 17. Within that same theme, let's also change the size of the title. So we're going to do element text and let's do size equals 21. We also want to make sure it's in the middle. So we do h just equals 0.5. We're adjusting it horizontally and let's make it bold so it stands out, people know what to look at. And let's do the same thing for the subtitle as well. So we're going to do element text again. We don't want it to be as big as the title, so let's only make it size 17 and let's put it in the middle as well. So let's run that. Let's just see what the output is. Let's see what we're looking at here. If it loads. While it loads, we're gonna do two more things. There we go. Okay, so let's just see what it looks like before we do anything else. So you can see here, okay, now it looks a little bit nicer, but again, still the browns are in the bottom left. We need to flip this y-axis, right? We want to flip it so that the best teams are at the top, not the best defending pass teams are at the top, not the bottom. So we're going to do scale y and then reverse. So we want to flip the y-axis. We're going to do breaks equals scales. And then this pretty breaks function, which basically says how many times we want to break up the y-axis. I like to do n equals 8. You can do n equals 6, n equals 5, however you want. And we're also going to do the same thing for the x-axis, except we're going to do scale x continuous. We want to leave it as it is, but again, we want to be able to say the same thing, n equals 8. Boom. So now, as we let this run and it loads for us, we can see kind of the final output of this, right? So I think I might have to reshare my screen. So hopefully you can see the graph now. I made the mistake last time, but in this preview, it's not going to show how it looks when you save it. So, but again, this is kind of what we're looking for: coverage, predictability, and defensive pass efficiency allowed for NFL defenses in 2023. And then we have the subtitle. And again, here, what we can see, the Browns have the best pass defense, but they're also a very predictable coverage unit, right? They run a couple of certain coverages a majority of the time. On the other hand, the Ravens and the Chiefs have very unpredictable coverage schemes, but they're also still a very good defense. You can kind of see there is somewhat of a negative correlation. The more complex your scheme is, the worse teams seem to perform. Obviously, you're going to have outliers like I guess the Browns do fall in that tier, in that line, but the Ravens, the Chiefs, I guess the Cardinals, all kind of outliers in their own sense, the Colts as well. So you can kind of see there is a negative correlation, which I find interesting. And if you want to kind of do this type of study on previous years, all you have to do, I just unshared my screen completely. All you have to do is go up here and just change the year, and you can see this for any other year. So again, if you want to, so now let's save this. Let's save this graph to our folder. So what we're going to do, I'm just going to again copy paste it from my code, but we're going to call it cov entropy.png width equals 14, height equals 10, DPI equals retina. This is, in my opinion, the best kind of formatting you can do for saving. And then for me, this is in the MFans coding tutorials. And if you click on this, the cov entropy thing, it should pop up in another screen or your preview if you have a Mac. And then to me, it looks good. You're not going to see it, but again, you can kind of see it in the plot section here. We already pulled it up. but that is how I want it to look. So mission accomplished. What we were able to do, we were able to look at unpredictability for defensive coverages or defensive coverage schemes and how that translates to, how efficient they are at stopping the pass. So now there are a couple other things, or one thing I did want to look at in relations to the new coverage data. Let's just, create something that would be worthwhile to post to Twitter or, put in some article for you guys. So what we're going to do is cover rates EPA. We're going to take the data from the play-by-play data set. We're going to group by def team, and defense coverage type, just like we did last time. We're going to summarize. Again, we're going to do plays equals n, which is just the number of rows. But this time, let's add some stats to it. So we're going to do EPA per play equals mean EPA, filter out the any negative EPA or any NA EPA plays. We're going to do success rate equals mean success, which success rate basically, or success on a play basically means was the EPA greater than 0. And then we're also going to do yards per play, which is just the average yards gained on a play. And also we again want to filter this so that the defense coverage type isn't other. So we're looking at actual charted coverage plays. And then we want to left join with teams logos colors. But within the teams logos colors, let's only select the team abbreviation and the team. Let's do the word mark. And then again, by equals C, def team equals team abbreviation. So now with this data set, this isn't how we initially had it, but for what we're going to do, I think it works out fine. So we have this table now. So now let's create, or we have this data frame. Now let's create a GT table, just like we did last time for, I believe it was the Bills for the run pass tendencies tutorial. But what we're going to do is we're going to do cover rates EPA. Let's first do an ungroup. And then let's not select, or let's select the team word mark. We basically want to arrange how we want the table to look. So let's have the team word mark first. Let's do the defense coverage type second, plays EPA per play, success rate, yard per play. And then what we can do, let's just quickly look at how the table is set up. Now, obviously this, what does this do, right? Nothing. Or I guess I didn't even do this correctly. We're going to select those, and then we're not going to select those. We're going to first, above the select function, we're going to do filter, and let's just look at the Kansas City Chiefs, because that was the team that had the highest unpredictability score in terms of coverage scheme. So we're going to do filter def team equals KC now, and then pipe that, and then now let's look at what this looks like. Okay, so this is Kansas City's coverage scheme. Our table of coverages, how efficient they are, and the number of times they run it. So what we want to do first, let's arrange this by the number of plays. So we want the coverage with the most number of plays at the top, and then we go from there. And to get rid of this team word mark, we're going to do GT IMG rows, and then columns equals team word mark. So now we have a table, right? We have how often the Chiefs are on cover 1, cover 4, any coverage. We have their EPA per play, we have their success rate allowed, and we have their yards per play allowed. But this still isn't clean. Like, let's make it a little bit cleaner. We don't need, 8 decimal places for each thing. So let's do FMT number. We want to change the EPA per play column and the yards per play column, and we only want to make them 2 decimals. Success rate, technically it is a technically success rate should be a percent. So we're going to do FMT percent columns equals success rate, and we're also going to make that 2 decimals, and that turns this into a percent. Now this looks much cleaner, right? We have the team, we have the coverage type, number of plays, we have the EPA per play, success rate allowed, yards per play allowed. Again, there are some other things we can do. Some of my favorite add-ons to a GT table, Optro striping. I think it just makes it look much cleaner. Also want to add a theme to it. So let's do GT theme 538. And then let's create a title. So tab header title equals Chiefs defensive coverage breakdown in the 2023 season. And that's it. And let's see what this looks like. Oh, that should be in a pipe. There we go. So now we have a table, right? We have the defensive coverage type for each team. Now this looks clean, but this could be cleaner, right? What else are we missing? Well, the team word mark and the team defensive coverage type, like those column names don't really look that clean. So we want to change that. So what we're gonna do, let's do a Coles label, just like we did last time for the Bills thing. We're gonna do team word mark equals, let's just change this to defense. We're going to do defensive coverage type equals coverage. Plays on, we don't need to change the plays column. EPA play should be EP. Technically, it should be EPA per attempt. Success rate equals, let's put a space in there. So success rate, also capitalize it. And then yards per play. Honestly, we can just leave yards per play the way it is. And boom. And now we have a table. So again, how do we save this table? Let's do KC table. Let's save this entire table into a data frame or into an object. So it's going to save here as KC table. Then we do a GT save KC table, KC table.png. So now this saves it as a PNG. Again, it goes into this folder or whatever folder you're saving everything out of. You can click it. It should open up in whatever preview application you have on your computer, and you should be able to see this table as a PNG, which you can post to Twitter, you can post to Instagram, Threads, in an article, whatever you want. So that's how you do that for defenses. One challenge, if you guys want a little challenge to practice on your own during the rest of the holidays or in the future, make this table, but instead of using defenses or instead of looking at it from a defensive perspective, look at it from a QB perspective. How often do QBs see certain coverages? What are the QBs stats when facing a certain coverage? I'm going to leave it up to you guys to figure out, how you can do that, how you can filter that for a certain passer. And basically it should be this whole section right here. You just have to play around with some of the names. And then I'll give you a hint. If you do that, I wouldn't recommend doing this line. But everything else is fair game. And I'd recommend anyone trying it out to kind of challenge themselves and see if they can come up with this table, but for, say, Patrick Mahomes, right? I think that could be a really, really cool exercise and a good way to kind of put your skills and what you hopefully learned in this tutorial to the test. So again, to recap, everything we did, we loaded in the data, we changed some of the column names to make it look nice and pretty and how it looks in this table right here instead of like a all uppercase with an underscore. We did some data exploration, just seeing like what types of biases are included in the data. We created data frames and we made it so that it comes out in this type of format. And we learned about the calculation for Shannon entropy. We created a graph, which basically looks at how predictable coverage schemes are, as well as how that translates to their passing efficiency allowed. And then we looked at, we basically found out how to make a table for how often each team runs each coverage, along with stats that follow that up. So that's it for today's tutorial. Hope everyone had a great holiday, have a great winter break for any of any of the fellow college kids out here. Feel free to hit me up at ArjunMenon100 on Twitter with any questions or anything you might have or any suggestions for future tutorials. I really do enjoy making some of these and giving back to people and kind of helping out wherever and whenever I can. So again, that's going to wrap it up. If you have any questions, Twitter, if you need help with the code, my GitHub at ArjunMenon100 on GitHub or at ArjunMenon10. Go to the Advanced Coding Tutorials page, and then it's tutorial number 2. But thanks again, everyone. Happy holidays, happy new year. And until next time, hope everyone is doing well and has a great 2024. Thanks.